Okay, going to do a quick tutorial on how to make a capacitive discharge launcher for model rockets. And first thing you need is a disposable camera flash. I started making these probably 15-20 years ago at least. And it looks like, quick look at Amazon says they still sell the exact same one. And let me just point out a couple features on here. So this is the flash. This is obviously the lens. That is the button that charges the flash. So this is actually the same exact body, and you'll see that there's a little button right here. That's this charging button right here, and that'll be important later. But you can obviously buy it and take it apart, or what I used to do is I just went to Target or CVS, to their camera department, and said, hey, look, I'm doing a little science experiment. Do you have any disposable cameras that I can have? And they'd say, oh yeah, we're just going to recycle them. So here, take what you want. And that's how I ended up with all these bits and pieces. Now, the first thing I need to explain is how this works. It's a little bit different. This is kind of my Gen 2, this is my Gen 3, and this is really a quick and dirty one I did for a launch, which I'll explain later, but all the guts are exposed, and that makes it really easy for me to show you what I did. The first thing you understand is you don't just hook things up and fire away, because you have to make sure the capacitors are charged. Now, in the disposable camera, they just have a single capacitor and a single AA battery to charge it, because all they're doing is powering the flash. But in this case, I think you could probably do a single solar igniter with just the one capacitor. But if you want to do clusters, or as you saw, if you want to just vaporize a couple inches of nichrome, you need a little bit more power than that. So what I did is I just put them all in parallel. This one, if I remember correctly, has about 60 joules. It's got what? 1, 2, 3. It's got 6 capacitors there. And this guy here has, I think, about double that. These are actually large capacitors, if I remember correctly. This one runs off of AA's. Okay. And there's a couple of little things I did in here that I decided to omit when I made this one. So this is really a simpler one, but this one has about twice the total power as this one. So I still keep this around if I'm doing clusters. It's just more reliable. So how do you convert this, and how do you operate this? The first thing you do, obviously, you put the batteries in. This one takes AAA's. Once you put the batteries in, you have to charge it. And let's see. Not hearing. Normally there's a whine, but I guess it's not whining right now. Oh, there it goes. And then after a little bit, there you go. This will start blinking, and that tells you that your capacitors are charged. At that point, you can hook up your what's that called? Your clips. Obviously, I use an extension to this, but it's the same connectors. I use this, which is just speaker wire. It's quite thin, as you can see, and this I think is about 25-30 feet worth. But the small gauge doesn't matter, because I'm dumping 350 volts through. This is another thing that I do with my clips. I have them at different lengths, so that makes it harder for them to short out. One thing to understand is if your clips somehow fall off the igniter, nothing will happen, because this actually relies on the continuity of this to fire. And I'll explain a little bit more about that later. So right now, if you just throw the safety key in and you hit launch, you can hit that all day and nothing happens. No power really goes anywhere, because it actually needs this to complete the circuit. Okay. that is one slight, I guess you could say, drawback of the system. You have to really make sure that your all your connectors to the igniter are secure. Otherwise, you know, if it falls off, then it's just not going to do anything. Okay, so once you take apart your camera, the first thing you really need to do is short out the capacitor. The reason for that is you will almost always have residual charge. This one isn't charged right now, but you take a screwdriver or something and just short it out, and short it out more than once to make sure there's no residual charge after you do the first one, because telling you from experience, you don't want to touch 350 volts in a capacitor. Now, originally, as you saw in this one, I would have a momentary switch to mimic this momentary switch, okay? But I figured out later, well, I don't really need to do that, because I can just short that out and then just control it with the power, basically the battery. So if you imagine this as a black box, there's a black box, you've got a AA battery over here. So you desolder these, just remember which the polarity is, and now that becomes your power in. Okay, so that's one set of wires you need to do. The second thing you need to do is you need to short out this momentary switch. And you can see, oops, you can see from this one, that's just what I did. I just soldered a wire across that, so that basically, that's no longer functional. It just shorts it out. Then, oh, I forgot to mention, you probably want to put a switch. So we'll say you put a switch here, okay? And that's, I don't have enough room to draw a proper switch symbol, but that's a switch there. Note where your capacitor is. Note that the capacitor does have a polarity. So in this case, that one's a negative and that's a positive. And you just basically build up, you know, you need to get more than a few of these disposable camera flashes. These are in parallel, which means that all the positives are together. We'll use red to show the positives. So the positives are all positive and the negatives are all connected to the negatives. So that's kind of crude, but you get the general idea. Okay, so that's the second thing you need to do. And then in this case, we've obviously got a safety plug. That's just a really small, I went to Radio Shack. You know, I don't know. Radio Shack's been gone for so many years, but that's just a little audio plug. And that basically allows you to have a safety key. But the safety key then goes onto the trigger. So it's kind of hard to show you where the trigger is. Let's go over this one. I don't remember if I explained already. This is so I could go to a range event where they were using a rack, and they were going to basically hit me with 12 volts. So in this case, the 12 volts hits an automotive relay, which then triggers this guy. So in this case, you could see that the trigger went to these 2 points. This is a slightly different circuit. Yeah, what you'll see is when you take apart the camera flash, you'll see that there's 2 pieces that are, the circuit will close when the shutter releases. So I guess that's the other thing you need to do when you take apart the camera. Look for which 2 contacts the shutter is connecting to make the flash trigger. And I don't recall which ones it is on this one. Let's see if it's visible in here. Oops. See, I'm trying to get my timer. Okay. I want to try to keep this under 15 minutes, so I may have to break this into a second one because YouTube makes it a real pain to upload longer than 15. Yeah, it's too hard to see where it is in that one. And then this one, actually, this isn't a Kodak either. This was a Fuji because that circuit board is so small. And I would, if you have Kapton tape, I would use it. That's what this yellow tape is. It's a high voltage insulating tape. Okay, well, so you basically have the trigger, and that again goes to the flash, and that basically is the button that you will push. Now the safety key, and we'll call the trigger number 3. The safety key can be one in two places. It can be in series with the trigger, or it can be in series to your leads going to your rocket. Doesn't really matter. I prefer to put them in line with the trigger, but I think for this one, if I try to trace back, yeah, so this is actually in line with the launch button, in series with launch button. So let's just say that's what you should do. That's 4. Okay, and then the last thing, of course, is you need these leads. So where do those leads go? Well, that's a good question. When I built my first generation one, and that was the one before this, the leads basically went directly through the trigger to the capacitors. So that meant I was dumping the capacitors right through the trigger, right to the rocket, and I was basically treating everything. I was treating these just like a normal battery. The problem with that is, at 350 volts, when you close this switch, you get such arcing that after, I don't know, a dozen launches or something, carbon would build up and it would start shorting through this. So it would actually launch, it would actually trigger the capacitors once it reached a certain voltage. It would just short out through the carbon that had built up. So Jim Thackert, who is with my club, had suggested that I actually trigger through the coil. And I'm actually coming up on time now. So I will make another video here to explain that part. So hold on for part 2.